Welcome. I am Gregor Reischle, founder of AM Entrepreneur. This explained qualified AM program targets reproducible supply chain powered by additive manufacturing. I am the standard initiator and the supporter and the project manager since many years. And right now in the position to explain to you how standard support controlled supply chain within additive manufacturing. I hope you enjoy the course. If you have any question, please feel free to contact me. I am really happy to get some feedback and really to support you with the fast and cost-effective implementation of 100% control within additive manufacturing. Let's understand the motivation behind additive manufacturing and ASML's high-performance systems. So first of all, there are multiple system variants from ASML. Some older ones which are refurbished, some present ones like this one here, the EUVOW NXE system, which is the high-performance system which today delivers the most advanced microchips in the world. And of course, there's a future outlook into the future system, which even deliver faster processes and much more higher advanced microchips. So this motivation, and as we all know, we are all electronic gadgets and tools consumers, will not stop to investigate better performance in our electronic devices. That's provided, of course, by high performance microchips. Additive manufacturing can play and is playing already a significant role. It improves the components' delivery time, availability on demands, but as well technical features like dynamics and cooling features. So here we see one beautiful example, very easy to understand. You see the part on the left, which has sharp corners and kind of high transitions, and through this as well kind of high disturbance forces. Within how is it designed conventional based. On the right side, the actual same part performance is assured with additive manufacturing and with much more improved dynamic and disturbance performance behaviors. And so easy it is. You have an additive technology which enables the designer to optimize the flows where disturbance happens, and through that we optimize system performance. Here we see as another fantastic example of this conditioning ring, where with additive manufacturing internal channels, which you see on the right side, which were designed into the part, improved conditioning were mastered, and we see a thermal improved performance by 6 times and dynamic improved performance by 15%. Let's understand the challenge within additive manufacturing. For those of you which are not involved, additive since over 30 years in development, but if we look at the production capability, only few processes like powder bed fusion metal are already in production. Some others are targeting those or getting closer, but in general, powder bed fusion metal is the most advanced process to be used for production. Still, certain types of systems and material combinations are very innovative. As well, the mixture of complex design and innovative process cause even more complexity in qualification. If you look at this part here in the picture, we have surface demands, we have dynamic behavior demands, we have internal channel surface roughness quality demands, and this is caused by build process calibration. This is caused by material and system reproducibility. So the feedstock material and the system IQ needs to be always reproducible and assured. The people which are working around the systems need to work in each working step on the same quality level every day. And of course, the entire post process, which assures that the final part property is reproducibly in that quality what the system is requiring, is aligned within the entire manufacturing flow and controlled. That's a very complex task to meet, and that's why we really need qualified AM on a standardized level, so we can share this complex validation chart, share between the AM system owner and supplier of printing services, those which are capable to improve the designs, define the designs, so the designer of ASML, for example, which can slightly optimize a design that it's better controllable for the manufacturing process. And of course, the supply chain managers, which are capable to evaluate the risks coming with the new machine setup or new design of systems, and to better control the future supply chain. One first very important element of such a solution is to understand what's the business impact of a particular part. So in the case which I just showed from ASML systems, I guess that's quite clear. The system performance improvement is key. In other businesses, sometimes we really need to take a deeper look if there's a market, if there's a competitive technology which can produce the part maybe cheaper, if there's a sustainability aspect which contributes that the part is better manufactured with additive, if there's a design add-on value, if there's a fabrication match where we combine with other technologies to utilize the additive potential even better. So all such an aspect. And of course, finally, the quality enhancements, what comes to the customer and is understood as a better value, clear for ASML's next level machines with high performance output, maybe not always clear with all other additive parts. So exactly this is what I mean by AM business value. This needs to be understood. If this is there, we know that the cost of qualification will pay off. So let's have a look into this standard, which I am designing since many, many years. Here you see this overview from manufacturability assessment review till post-process. In between, there's a data preparation, system setup, build cycle, so the actual building of the parts, and process finalization steps. The granularity is much more higher, but for the first technical overview, that's a fantastic picture because you see in one overview all very relevant process steps to define. So it's a very high level process step, but for sure a very significant to manage and easy to manage because it's standardized based on a 52920 standard. And we can integrate into this standard other supporting standards wherever they are required. This is an example how we did within the ASML GSA, the supply requirements for additive manufacturing parts. And you see that the 52920 standard interconnects with particular other standards, which are as well of high importance in a single domains of interest. For example, the domain 3, and below here you see ISO STM 52907 and 52928, which are in charge of making sure that the feedstock management is very controlled, because feedstock in powder bed fusion processes, so the material, the powder, is to manage very sensitively. Otherwise, we don't have 100% evidence of part quality. Another very important aspect, how the standard 52920 intercollects with the existing management standards in the companies. ISO 9001, 13485, 9100, other management standards in general. So here you see this overview, and the green marked areas of the 9001 are in correlation with the 52920. What does that mean for those which are implementing the standard? This means either they are preparing as well to serve the demands of the ISO 9001 and other management standards, or they have already a 9001 certification and widen it using 52920 to the additive manufacturing production. Here you see the one insight of the 52920, the integration of human and data-driven quality assurance. The entire standard 52920 has 140 shell requirements, and roughly 20% of those shell requirements is today digitally traceable. So which means that only 20% of this standard we can really use for digital tracing, and the other portion, the 80%, is mainly driven by human head and hand. So that's why it's so important that we implement this standard, because the human head and hand on daily production routines have significant impact on part quality. Another very important solution insight is the build process qualification. So every powder bed fusion process, which is 1/3 of additive manufacturing, a process category so-called, powder bed fusion metal, we need to have a solid IQ/OQ/PQ and validation of his system setup, of his material and process parameter combination, and reproducible results over the entire build envelope. This has to be proven by data. Those data needs to be tested on regular basis and provided to the OEM, the critical part owner, on a regular basis, to have the evidence that those parts manufactured 100% under the validated state. So let's talk about the implementation. So implementing such a system requires, of course, documentation. Without documentation, we don't have the proof of conformity, how the human behaves in each process step, at least theoretical. We assume if we teach the human and document the teaching in his daily operations, then it's followed, that this is followed. And this can be trained, this can be supervised, this can be signed, and this can be kind of monitored, by supervisors. So that's why a QMS, a quality management system containing working description, SOPs, and checklists, is the actual proof of human being in a controlled production environment integrated. So if you establish such a system, you get the proof of conformity, which is an audit-based proof of conformity. So an auditor like me goes through the production and audits according standards if all shell requirements are met within this production line. And thirdly, you start to produce with this proof of conformity, start to co-create new designs, new parts, and provide on a long-term evidence by statistic process control-based data evidence. Here you see my implementation supporting offer for all AM suppliers. So on the left side, you see a custom template which I have over 100 times available. And this supports the content of the standards which I'm referencing. For example, the 52920, what you see on the right side, contains of those processes which you see on the right side, and the templates which I offer supporting those processes. So they have the right structure, they have the right process map, they have the right shell requirements and focus, they have the right content already prepared, which only needs to be customizable to your AM technology, AM processes, daily operations in use. So you save cost and time while fulfilling the standardization and documentation requirements. From the supply chain manager perspective, if such a system is implemented, he has the evidence to work with a particular supplier, and then he knows that he has all his processes under control. They are documented, they can be monitored. In terms of accidentally something happens, we can go back in the process, analyze where the accident was or the mistakes happened, and provide a better solution in the future. As well, we have a proof of conformity for qualified AM build processes, which deliver reproducibility through SPC data. And we have an information for the designers at the OEM, so they know which processes are available already qualified. So I can rely on a test data and know what I get in my part. As well, we have a proof of conformity for high critical components, which then go behind the classical facility or production site proof of conformity. They really target part-specific qualification criteria, which works on top of the production site conformity and are integrated. So that's beautiful because we don't need to repeat everything what is required. So we would spend again per part 2 years. No, we are spending only for one single component this time, which is required to serve the part-specific high-end feature solutions. So to give a little bit more understanding how production side supplier qualification works together with the build process and the part-specific high-end requirements. Each part actually, which is produced with additive, should be risk assessed. This happens on a daily basis and a manufacturing site which is qualified. So the incoming inquiry is analyzed for being capable to deliver. And this analysis happens on a standardized level at qualified suppliers on an industrial level. If they discover that those parts have new demands, new mechanical properties or geometrical accuracy demands which are not qualified yet, they establish a control plan, a mitigation plan to manage those new features. And probably they will widen the process validation, establish new approval procedure within the manufacturing flow. And finally, we have a on top working manufacturing flow on top of the existing already qualified production line, which only focuses on the part-specific features. This was a very first basic understanding of qualified AM program for part owners, supply managers, and as well for the suppliers. Please have an understanding that in this short time, it's not possible to go in a very detailed level of each stakeholder understanding. So feel free to contact me. I am happy to answer all your questions regarding the program, the complexity of each segment of the standards, on the implementation journey, on the audit and approval side, on the SPC method, how the data analysis works together with the audit process. And as well, I really strongly believe and know, because I have seen that already, that such a programs has an incredible benefit for the cost of qualification, for the security level of a supply chain, for risk management challenge of supply chains, for being capable to deliver alternative supply chain method, for replacing old school classical supply chain within the new additive manufacturing on-demand available supply chain, establishing new business model like digital spare part concept, establishing new part features like customized solution or customer-oriented design on demand, part in machine features. So the future is broad with this program. Please help to implement it. Ask me further question, and I'm happy to execute it with you together.